Is section 7.1 on the inverse sine, cosine, and tangent functions. So to begin our discussion, we're going to analyze the graph of f of x equals sine x. So notice its domain is all real numbers. Its amplitude is 1. The range, all the y values are bounded between -1 and 1 inclusive. And let's recall, this is a function. It passes the vertical line test, but it is not one-to-one. And remember, back when we studied inverse functions, we need a function to be one-to-one in order to find its inverse function. So what do? Well, what we do is we're going to restrict our sine curve to only the interval between -pi/2 and pi/2, the portion there in blue that I just highlighted again. Now, if I only look at that portion of the graph, would you guys agree that now the function is one-to-one? See, it passes the vertical line test and it passes the horizontal line test. And also this portion of the curve achieves all the values of the range. So still the range will be -1-1. I haven't cut anything off. So this is basically how we find our sine inverse function. I'm only going to consider this portion of my sine graph. So what I'm going to do is restrict the domain on sine of x from -pi/2 to pi/2. And then the range is going to be the same, right? The range will just be from -1 to 1. Now let's just sketch a quick graph of what y equals sine inverse of x looks like. To help us do that, I just want to identify 3 points. And if you think back to when we graphed inverse functions, remember we could just take points x, y and interchange the coordinates, and that would give us points that are on the graph of the inverse. So this first coordinate here, this is -pi/2, -1. This is 0, 0. And this is pi/2, 1. So that means on the graph of y equals sine inverse of x, I'm going to have the following 3 points. Instead of -pi/2, -1, I'm going to have -1, -pi/2. 0, 0 stays the same, and then I have 1, pi/2. Now let's draw our x and y axes. And the labeling is going to switch. So instead of x being between -pi/2 and pi/2, it's going to be between -1 and 1. And y is going to be between -pi/2 and pi/2. So everything switches. X and y get interchanged. And then let's plot those 3 points. So I have 1, pi/2, 0, 0, and then -1, pi/2. So it looks something like this. That's y equals sine inverse of x. All right, well, what does this mean for us? Well, we just have to keep in mind that we have that domain and range restriction on sine inverse of x. So here, for the inverse function, this is for the inverse, y equals sine inverse of x means x equals sine of y, right? And x is bounded between -1 and 1, meaning my argument here has to always be between -1 and 1. And y, my range, is between -pi/2 and pi/2. We're going to keep this in mind later on when we're solving some problems that involve sine inverse. The range is only between -pi/2 and pi/2. That's quadrants 1 and 4, right? So let's draw where -pi/2 and pi/2 would be. So here's -pi/2, and here's pi/2. So you're only going to give angles that lie within this range, okay, when dealing with sine inverse. Now let's look at f of x equals cosine x. We have to do the same thing since we know cosine of x is not one-to-one. However, it would not work for me to cut it from -pi/2 to pi/2 the way we cut sine. Do you see why it's a problem? Look at that green portion that I just drew. From -pi/2 to pi/2, we have 2 issues. First of all, cosine of x is not one-to-one on that interval. And second of all, the range would only take on the values from 0 to 1. So I would be missing the whole portion of the graph that takes on values from -1 to 0. So that's not going to work. Where do we have to cut cosine? We cut it from 0 to pi. All right? So in that case, our graph is going to look pretty similar, and if you want to plot it on your own, I encourage you to do so. You would just take these points 0, 1, This would be pi over 2, 0. And the last one here would be pi negative 1. And you can plot that. For our purposes, the most important thing you need to remember is that y equals cosine of x, its range is restricted between 0 and pi. So that's quadrants 1 and 2. Now lastly, we're going to consider tangent of x. Its inverse is pretty easy to find as long as we consider only one period, right? So if I consider only one cycle from negative pi over 2 to pi over 2, on this portion, tangent is 1 to 1. It passes both the horizontal and vertical line test. So as long as I just restrict to only one period, we're ready to roll. Just keep in mind here that the values of negative pi over 2 and pi over 2 are not included. So this actually, fix this here. This should not be inclusive. Y should be bounded between pi over 2 and negative pi over 2, not inclusive. I actually do want to draw y equals tangent inverse of x because this is very important, especially when you get to calculus 2. So you need to know the graph of this one. And even in calculus 1, you'll use it for some limits. So actually, this is a pretty popular one, this tan inverse. All right, it's pretty fun to draw. Instead of having vertical asymptotes at negative pi over 2 and pi over 2, guess what happens? We have horizontal asymptotes at pi over 2 and negative pi over 2. So we'll draw our horizontal asymptotes here. Okay, and then we'll still go through the point 0, 0. And tan inverse is still an increasing function. It looks like cube root of x, basically, but it's bounded between two horizontal asymptotes. Okay, so this is the graph of y equals tan inverse of x. And I know we talked about end behavior a few chapters ago with limits. So something that you'll see later on, here's a little sneak preview of next semester. You might be asked, what is the limit as x approaches infinity of tan inverse of x? So what are the y values approaching as x approaches positive infinity? Well, the answer would be positive pi over 2. And then the limit as x approaches negative infinity of tan inverse of x. If we go the other way, that's approaching negative pi over 2. Okay, you don't need to worry about remembering all that for this class. Just remember the graph because it's going to be super useful in the rest of your math career. Okay, lovely. So here we go. Let's look at some examples now. And a lot of this you have to just do in your head. I'll try to write out as much as I can for computation to help you. So first one is find the exact value of each expression. Sine inverse of negative 1/2. Now remember, the range on sine inverse is restricted from negative pi over 2 to pi over 2. So what I want to do is think to myself, all right, when is sine equal to negative 1/2? Well, that would be at a pi over 6 reference angle, okay? And if sine is going to be negative, and I can only give my answer between pi over 2 and negative pi over 2, it's going to have to be in quadrant 4. So what would the answer be? Well, it's going to be over here at negative pi over 6. And that's really it, okay? Now you might be wondering, would 11 pi over 6 be okay? It's coterminal with negative pi over 6, right? So remember, 11 pi over 6, positive 11 pi over 6 would be going this way, and it would be coterminal. What do you think the answer is? Would that be another possible solution? No. Remember, 11 pi over 6 is not in the interval from negative pi over 2 to pi over 2. Okay, so even though it's coterminal with negative pi over 6, it's not within the interval. And remember, this inverse function is going to be 1 to 1, so you will not have more than one possible answer. Also, if you're not convinced, I'm going to scroll up to the graph really quickly of sine. Remember we said we were restricting the domain to only values here. Well, where's 11 pi over 6? Can you find it for me? 11 pi over 6 is somewhere over here. Clearly, that's out of bounds. That's where 11 pi over 6 would be, right? Just a wee bit less than 2 pi. So that's not a possible answer. Think to yourself, I can only give values that are within this green portion from negative pi over 2 to pi over 2. All right, now that I've stressed that, let's move on to the next one. So sine inverse of 1. When is sine equal to positive 1? Imagining your unit circle, it'll be up at the top at pi over 2. Okay, that's it. No work really to show, right? As long as you know your unit circle, this shouldn't be a big deal. Now we're looking at cosine inverse. Okay, cosine inverse's domain is restricted from 0 to pi. So don't forget that. So cosine inverse of negative 1/2. So this time think to yourself, okay, if cosine is going to be negative, and I'm restricted from 0 to pi, in which quadrant am I giving my answer? Well, 0 to pi would be here, right? So we're going to be in quadrant 2 in order for cosine to be negative. And if it's negative 1/2, then we have a pi over 3 reference angle. So this is going to be 2 pi over 3. All right. Very nice. Next one, tan inverse of negative 1. So remember, tan inverse is restricted from negative pi over 2 to pi over 2. So when is tangent negative 1? Well, it's when sine and cosine have the same value at a pi over 4 reference angle. And if tangent's going to be negative, right? And tangent is like sine. It's only in quadrants 1 and 4 for its inverse, tan inverse, excuse me. If it's going to be negative, then we're going to be over here in quadrant 4. And if it's a pi over 4 reference angle, then this is just negative pi over 4. Okay, not so bad. Last one of these kind is tan inverse of rad 3 over 3. So what I like to do with these is think about what it was before the denominator was rationalized, right? So if it's rad 3 over 3, that means originally it was 1 over rad 3. And we know tangent is sine over cosine. So that means sine was 1/2 and cosine was rad 3 over 2. So if sine is 1/2 and cosine is rad 3 over 2, then that means we have a pi over 6 reference angle. And since tangent's positive, then we're in quadrant 1. So the answer is just going to be pi over 6. All right. Good. If you haven't memorized your unit circle, this is definitely going to be challenging for you. So I recommend you get that under control. There's lots of free blank unit circles you can download in order to practice filling it in or whatnot. Okay, let's move on to some more examples now. Find the exact value, if any, of each composite function. So what you want to do for these, always start with the inside composition and work your way out. So start on the inside and then work your way out. Okay, so sine of negative pi over 10, I don't know what it is, right? It's not something from the unit circle. Let's see, where is negative pi over 10? It's in quadrant 4, right? So here's negative pi over 10. So I'm going to get some value there. Then I take sine inverse of that exact same ratio. So I'm just going to get back the angle I started with. Since negative pi over 10 is within the range of sine inverse, it's between negative pi over 2 and pi over 2, then when I apply the inverse and I compose it with the original function, I'm just going to get back negative pi over 10, which I started with. Okay. Good. Now example B is a little trickier. So we have cosine inverse of cosine of negative 5 pi over 3. Okay, so negative 5 pi over 3, let's see where that is. So here's our unit circle, negative 5 pi over 3, that would be over here. That's negative 5 pi over 3. And then if I apply cosine inverse, this time I'm not going to get back negative 5 pi over 3 because that's not within the interval from 0 to pi. So I have to give an angle that is coterminal with negative 5 pi over 3 that is within the interval from 0 to pi. Can you tell what it would be? It's just positive pi over 3. Okay, so what's the difference between example A and example B? Well, example A, negative pi over 10, that was within the interval of negative pi over 2 to pi over 2 for sine inverse. So if I apply sine and then sine inverse, the inverse function and the original function basically undo each other, and I just get back the angle that I started with. But in the case with cosine inverse, because negative 5 pi over 3 is not within the interval 0 to pi, when I take cosine inverse of that quantity, I have to give an angle that's coterminal that is within 0 and pi. Okay. All right, example C, tan inverse of tangent of pi over 2. Now don't just be all careless and cancel out the tan inverse and tangent. Start here on the inside, tangent of pi over 2. Well, what is tangent of pi over 2? That's right, it's undefined because pi over 2, sine is equal to 1, cosine is equal to 0, so this is undefined, which means game over. You can't apply tan inverse after that. Last one, example D, sine of sine inverse of negative 2. So what is sine inverse of negative 2? What angle has a sine of negative 2? Can you think of one? No, you shouldn't be able to. This is not possible. Why is that? Well, think about your graph of sine x, or think about the unit circle. It's bounded between negative 1 and 1. So it's not possible for sine to ever equal negative 2. So again, this one is undefined. All right, these can be tricky, so be patient with yourself while you're working on them in the homework. And if you walk it through, explain it to somebody else, it'll help reinforce the ideas in your mind, because there really isn't a lot of computation going on. You have to do the reasoning in your head. So reason out loud, explain it to somebody else. That way you make sure you understand completely what's going on. All right. Next example, we're going to find the inverse function for each of these functions here, and then find the range of f and the domain and range of the inverse function. So this is something that we've done before, but now we're working with these trig functions here. Okay, so to find the inverse function, first thing I do is I replace f of x with y. So we have y equals 2 tan x minus 3. And then I'm going to interchange x and y. So I have x equals 2 tan y minus 3. And then remember, my goal is to isolate or solve for the new y. So x plus 3 divided by 2 equals tangent of y. And then I can apply tan inverse to both sides. So then I get y equals tan inverse of x plus 3 over 2. So now I'm almost done. I'm just going to replace y with f inverse of x, and that equals tan inverse of x plus 3 divided by 2. So there's that part done. Now I need to find the range of f and the domain and range of the inverse function. Okay, so I think we also need to list the domain of f. That way it'll help us find the domain and range of the inverse function. Don't you agree? So f of x is 2 tan x minus 3. Remember, we have to restrict the domain for tangent. So the domain of f is going to be from negative pi over 2 to pi over 2. And the range of f, the range of tan inverse, is from negative infinity to infinity. So what does that mean? Well, the domain of f inverse is going to be the range of f. So the domain is going to be negative infinity to infinity. But the range of f inverse is going to be the domain of my original function f, which is from negative pi over 2 to pi over 2. Okay, good. So we did a little more than they wanted, but really we needed to consider all of these cases in order to answer the question. All right, lastly, we have f of x equals 2 cosine 3x plus 2. Notice they already gave me the domain here. That's because if we were to try to graph this curve, we know that there's been a phase shift and a change in the period. So what does that mean? Well, that means that we can't restrict cosine from 0 to pi the way we normally do. So the phase shift and the change in the period need us to restrict it to this interval that's given here. So nice, they gave us the interval in order for it to be 1 to 1. So basically 0 to pi wouldn't work anymore because of the phase shift and the change in the period. Okay, so you don't have to stress, they took care of it for you. And let's go ahead and just find the inverse now. So I'm going to replace f of x with y equals 2 cosine 3x plus 2, and then switch x and y, so I have x equals 2 cosine 3y plus 2. Nice, I want to isolate the trig function, so I have x divided by 2 equals cosine of 3y plus 2, and then now I'm going to apply cosine inverse. So I have cosine inverse of x over 2 equals 3y plus 2. And then to get y by itself, I just need to subtract 2 and divide by 3. So I have y equals cosine inverse of x over 2 minus 2 over 3. And that's not the prettiest looking function I've ever seen, but it is what it is. So I'll relabel this f inverse of x equals cosine inverse of x over 2 minus 2 over 3. And let's box that. That's our first part. And then let's go ahead and give the domain and range of everything here. So the domain of f they gave me. It's that interval from negative 2/3 to negative 2/3 plus pi thirds. Now, what about the range of f? Ooh, well, look at f. F is a cosine graph, and here the amplitude is 2. So that means we don't have to graph it, but if we did, the y values would be bounded between negative 2 and 2. All right? And then now to get the domain and range for the inverse, you just interchange the two intervals. So the domain for f inverse would be from negative 2 to 2. And the range for f inverse would be negative 2/3 to negative 2/3 plus pi thirds. Now, if you don't write it in interval notation the way I did, be super careful for the range, because you would have to say the range is the set of all y values for the inverse, such that negative 2/3 is less than or equal to y is less than or equal to negative 2/3 plus pi thirds. So don't leave it as x. Remember, if it's a range, it's a bound on the y values. All right? Good, looks good. Now we're going to conclude the section with a couple examples here, solving equations. So find the exact solution of each equation. Notice the inverse is already there, which means we're going to give our answers restricted to the range of the inverse. Okay, so I'm going to isolate cosine inverse of x equals pi over 2. How do I get x by itself? Well, let me rewrite this equation one line below. If cosine inverse of x equals pi over 2, I'm going to apply or take the cosine of both sides. So on the left-hand side, I'm just going to be left with x, right? Cosine and cosine inverse will undo each other, equals cosine of pi over 2. And what's cosine of pi over 2? It's just 0. So that's the answer that goes in our solution set. Not too bad, right? All right, last one. We want to group the inverse trig functions together, and then I'll move the constants to the other side. So 5 sine inverse of x minus 2 sine inverse of x, that gives me 3 sine inverse of x. And then I'm going to add 2 pi. Add 2 pi. So that means on the other side I have negative pi. Okay, looks good. Now let's divide by 3. So I have sine inverse of x equals negative pi over 3. And then similar to last time, I'm going to take sine of both sides. So now on the left-hand side, I just have x. And then let's think, what's sine of negative pi over 3? Well, it's going to be rad 3 over 2, but it's negative because we're in quadrant 4. So that's our solution, negative rad 3 over 2. All right, so that's it for section 7.1. Hope you enjoyed it and get going on your homework.